What is up, everyone? I hope you all are doing well. My name is Ishan and welcome to the video. In the last video, we spoke about Europa and why it's such a unique world in our solar system that we have the Europa Clipper mission that's planned to go there to study its environment. If you haven't watched that video yet, pause this one, go watch that video because it has a lot of contextual information that's going to help you understand what's in the main chunk of this video. In this video, we'll talk about the Europa Clipper mission that's going to be going to Europa over the next few years, starting with the mission has three main scientific objectives that we hope to address with the scientific instruments on board. The first objective is to characterize the ice shell and the expected ocean underneath, which means that the mission is going to help us confirm whether there is indeed liquid water underneath the icy shell of Europa's surface and estimate the size, saltiness, and other properties of the subsurface ocean. It's also going to help us determine how the ocean interacts with the surface in a way where does anything from the bottom of the ocean work its way up to the surface, or vice versa, where stuff from the surface trickles down through cracks or fractures in the icy shell down into the ocean and to the bottom of it. The second objective is to characterize Europa's composition, including any non-ice materials on the surface and in the atmosphere, and specifically looking for any carbon-containing compounds. This helps us determine if Europa has the ingredients to permit and sustain life as we know it, because all the life that we know it is carbon-based. The third scientific objective is to characterize Europa's geology, including the surface features and localities of high science interest, which means that it will study how some of the surface features formed and any signs of recent activity such as sliding crust plates due to moonquakes or plumes that are venting water into space, confirming any geological activity. To address these goals, the orbiter has different scientific instruments on board, and I could run you down all the instruments name by name, but instead what I'm going to do is I'm going to link the NASA website that has all this information summarized in a really good format, and if you really want to get into the details of it, you can. But I'm going to run through the list and I'm going to talk about in more simple terms as to what that scientific payload is supposed to do. So we have two pieces of equipment that are part of the imagers or camera system. Basically, it has very nice cameras on board. It's going to give us the most highest resolution images of Europa that we've ever gotten historically. And it also has a thermal emission imaging system, basically heat vision, where the thermal imager is going to use infrared light to distinguish the warmer regions where liquid water may be near the surface or might have erupted onto the surface. So it has a nice camera on board and also has heat vision. Imagers and spectrometry wise, it has a UV or ultraviolet spectrograph, because by collecting UV light with a telescope and creating images, it can help us determine the composition of Europa's atmospheric gases and surface materials while also looking for any plume activity that we might expect. It also has a mapping imaging spectrometer, which is similar to the heat vision in a sense where it uses infrared light and it's going to map the composition and distribution of the ices, salts, organics, and the warmest hotspots. It has a magnetometer on board that's going to study its magnetic field and aims to confirm if Europa's subsurface ocean exists. It's going to measure its depth, salinity, and the moon's ice shell thickness. It will also study the ionized atmosphere and how it interacts with that of Jupiter. It has a plasma instrument for magnetic sounding as well, which is primarily there to distinguish the distortions from Europa's induced magnetic field and how it's interacting with Jupiter's magnetic field. For radar and gravity, which is relatively standard for space exploration missions to have these payload on board. Gravity and radio science, we're going to try to figure out what gravity looks like at different points in Europa's eccentric orbit, where it's not in a circular orbit around Jupiter, which means that it experiences different forces at different times, depending on how close or far it is from Jupiter. And this instrument on board is going to help us determine what the gravity is like in different in different positions in its orbit, which is going to give us a better idea of what its internal substructure is like. There's also a radar on board, and that ice penetrating radar will probe Europa's icy shelf for reflections from the moon's suspected ocean, study the ice's structure, thickness, and also help us understand a little bit more about the surface features, topography, composition, and roughness. Getting into the meaty stuff for chemical analysis, really honing in down into the potential habitability and organics that might be present. We have a mass spectrometer on board which will analyze gases both in its atmosphere and any possible plumes. It will study the chemistry of the suspected subsurface ocean through these plume activities and how the ocean and surface exchange material and how radiation alters compounds on the surface. It also has a dust analyzer on board, which, if you remember from the last video, there's tiny micrometeorites that bombard Europa's surface, which blast off dust into space, and we hope to sample this dust along with any venting plumes to identify the material's chemistry, area of origin, offering more clues about Europa's oceans. The culmination of all these sophisticated instruments on board will help us learn more about Europa and its environment for potential habitability to sustain life as we know it. If you made it this far into the video, I just want to say I appreciate you so much for tuning in. If you got something out of the video, you learned something new, be sure to hit that thumbs up button, comment down any questions that you might have or any videos that you might want me to make in the future. And don't forget to hit that subscribe button so you don't miss out on any future videos. I'm gonna see y'all in the next one.